Hi, everyone, and thank you all for being here. My name is Ephraim Anirobi. I'm a senior software engineer at Astronomer and a committer and PMC member at Apache Airflow. So today, I want to show you how Airflow, a tool you may already be familiar with, is becoming a critical part of building and scaling modern AI applications powered by large language model, which is LLM. So yeah, let's get started. Um, we are going to talk why we orchestrate LLM workflows, and we understand why we do that, and we talk about Airflow and Ask Astro. Then talk about dynamic task mapping, which is what makes Airflow an ideal tool to use for LLM orchestration. Then I'll discuss about the Ask Astro architecture. Then we'll talk about integrations, LLM integrations in Airflow. Then we'll also now talk about real-world use cases of Airflow and Ask Astro. Like you see how Airflow is used to run LLM applications. So why do we orchestrate LLMs? LLMs are incredibly powerful, right? But raw model access is not enough to build reliable and production-ready applications. And the reason is that if you want to answer a user's question, like this, because LLM application uses retrieval augmented generation, which is RAG. So for you to answer a user's question, you have to ingest documentation, clean it, and format it, then generate embeddings and store the embedding in vector databases, right? And then you build the right prompt for model inference. Now, imagine doing all of that across hundreds or thousands of documents. That is where orchestration comes in, because if you have 1,000 documents and you want to, get these documents, clean it, generate embeddings, and store them in vector DBs, then build it, it's going to be tedious when you are doing it manually. So that is where orchestration comes in. It breaks these processes into steps that you can, repeat and, repeat across so many instances and do it cleanly for you. So that is where orchestration comes in. But how do we do orchestration? How do we orchestrate LLM app or any orchestration? And that is where you have Apache Airflow. So Apache Airflow is a battle-tested orchestrator, right? And it was originally designed for data engineering, but it has all the qualities you may find, like you may need in any LLM pipelines. Because with Airflow, you have scheduling, you have retries, dependency management, observability, and you also have a UI for managing complex workflows. And the most important thing is that Airflow is also Python-based, which means you can express your logic in Python code and Airflow running for you, because Airflow is Python and Python is expressive and developer-friendly. If features like dynamic workflows and event-driven scheduling is one thing that makes Airflow very suitable for LLM workloads. And we are going to see how Airflow works with that. Airflow is very mature. If you check the GitHub stars, it's more than 40,000 stars, and we have more than 3,000 contributors and millions of downloads every month. And based on the survey we did in 2024, sorry, about 92% of users recommended Airflow. That's to show you that people like it for any ETL or workflow work. So this is how Airflow looks like. This is how a task, a DAG in Airflow. So Airflow has what we call a DAG, and a DAG is just what holds your task, the task that you want to run or the jobs you want to run. And we have a concept of operator. And if you look at this line, you have the hello is the task, and the bash operator is the operator. And you want to call operator in Airflow. So the instance of that operator is a task. And let me just go through how this DAG works. So this is a task, and this is another task. There are two ways to define a task in Airflow. It's either you use this kind of type, or you use decorators. We have task.bash decorator. You can also use them instead of using the bash operator. But here we use a bash operator. And what this bash operator is doing is just echoing hello. But in your real application, you can run any kind of command here with bash operator. Now you have a task, and then you set dependencies between those tasks. So the first task has to run before the second one. And that is also what is displayed here. You have the hello task and also have the Airflow task. This is how Airflow looks like. And when you have run this task if you are running for a number of time, you have something like this. And going into any of the tasks, you see the logs of that task, and you can check other things like the task code, like I showed you in the previous slide. Have the task code, we have events, to report event, and if it has output, you can also see the SCOM here. And also, this is also how the UI looks. If you look here, there are some failed tasks, which is reported clearly by Airflow. So this shows you that some DAGs or some jobs failed. So each of these is a DAG run. And if you look here, we have a failed task, and you have a failed task this side. And it's also clearly showing here that you have 8 failed runs and all of that. So some of the runs are hiding. So yeah, but it's a total of 8 failed runs, and you can see it here. And you also see on the UI what made that task to fail. It shows the logging. That's why Airflow is good for any kind of workflow. Now, let's talk about dynamic task mapping, which is what makes Airflow ideal for LLM workflows. Because with task mapping, you can expand the task. Maybe you're expecting, you don't know the number of items you are getting from outside, right? So if it comes like 5 or 10, Airflow will expand the number of tasks and run them in parallel. So that is why Airflow is really ideal, and we are going to see it, how it is used in LLM workflows. And this is a typical DAG representing a dynamic task. So if you look here, we have an add task and we have a submit task. Now, if you look at this line, we are trying to expand the X value into a list of 100 items. And after the expansion, we submit. So the key here is this expand. You have the value that we have here as 10, but we expand the X values. So this will give us 100, 100 tasks for this particular task. And that is what you see here, 100 task instances. And all of the 100 task instances will run in parallel. So think of this, you are processing a lot of documents to ingest in your in a vector DB. So you are getting a lot of documents, and you have one task. Instead of defining 100 task instances, we just define one task that expands on the output of the number of documents that you get from the source. So if it is 100, it will expand it to 100 tasks. So you don't need to define 100 tasks, but you just use dynamic task mapping in Airflow to expand this to the number of documents that you want to ingest. Now, I want to just show us the expanded task instances. If you look here, these are all the expanded task instances. And if you click on any of the tasks, you also see the logs of that task. Okay, so in order to see Airflow in action, let me introduce Ask Astro to you. So it's an open source assistant designed to answer questions on Apache Airflow itself. And it's a RAG setup, which means it's an LLM plus a vector DB of rated documentations. What is important here is that Airflow is not just the subject of the project, but it actually solves issues here. Airflow orchestrates key processes here, such as ingesting documentation, chunking it, creating embedding, and updating feedback loops. We are going to see it. This is the link if you want to ask any question about Airflow. You follow this link and it will answer. We are going to demo it in the next slide. And this is the repo where you see the source code and see how everything was designed. So I'll talk about this Slack channel in next few slides. So let's do a quick demo of Ask Astro. So I can decide to ask what is DAG versioning, and this is DAG versioning. So it answers, this is a Airflow tray feature in Airflow. And you can see that it already has information about all these features and just answered with it now. So that is how Ask Astro works. Let's continue. Now, if you go to Airflow Slack and go to this Airflow-Astronomer Slack channel, you can see a lot of, you can ask Astro a question. For example, this user is asking washer task is getting skipped despite upstream failure, and is answering the question. And after answering the question, it will ask you to rate it, whether it is good or bad. And this rating is also used. There is a pipeline that Airflow runs that uses this rating to kind of update the model to make the answers better. Now, let's look at the high-level architecture of Ask Astro. So this is just a part of the architecture of Ask Astro, just the part that Airflow orchestrates. So what happens is that we have a DAG that on schedule gets document from GitHub issues, Astronomer documentation, Airflow documentations, Slack messages, Stack Overflow, and a lot of other places. And then use LangChain to pre-process and split those documents into chunks and generate embeddings using OpenAI, and also write it to Weaviate database. So Airflow does this and handles retries. If anything happens, it retries and also notify you that, yeah, this is what is happening. Like if you set alerts to know when any of these fails, it will notify you that something has failed and retry, depending on the number of retries that you set in Airflow. Another part of Ask Astro that Airflow orchestrates is the feedback loop. User will rate a question, rate an answer, and Airflow will ingest that answer, check whether that answer is useful or not, and if it is useful, it will store it in the Weaviate vector database. So from where Airflow will now be using it, from where Astro will use it to feedback the model, and the model will now be much better. It will now start to becoming much better and much smarter because you rated it, and LLM has also verified that the rating is okay. Then it will save it in the Weaviate database. Airflow orchestrates this, and as user, it also alerts you if there is any issue, and it also handles retries. Now, before we go further, there is something we call Airflow providers. It is just integrations that connect Airflow to external systems, external tools like cloud storage, API database, LLMs, and why it's really important is that it makes it easy for you to just use operators, which I explained before, that operators are just templates for tasks, that when you instantiate operator, you have a task that Airflow can run. So all these external tools have operators, hooks, or even sensors. An example of how you can use the operator and hooks to achieve your whatever you want to do. So it's kind of a plug and play when you want to use that service, instead of writing the boiler code, trying to connect the API, handle the API keys and all that. Airflow does it through what we call Airflow providers. So, and we have a lot of these providers in LLM providers. So currently we have this for Cohere, Weaviate, Pinecone, and PG Vector. And so if you are trying to ingest data in Weaviate, for example, Airflow already has operators that you can use to ingest that data or embed, create embedding. So any of these providers, you can use them to interact with LLM directly without trying to write the code yourself. And with Airflow provider Cohere, you can use Cohere embedding operator, and it also has a hook that you can use to connect to the API. And this makes it easy for you to use the API and not worry about the keys, because Airflow has a concept we call connections. Those connections help you to manage all your keys, external connections, so that you don't have to handle the keys yourself, right? And if you look at this, we have Cohere embedding operator by the right. Let me explain just a little bit of what is happening here. So here we get the country list and ingredient list. Then we expand this task, like I talked about dynamic mapping, we expand it into the number of countries and we get a recipe list. Now, this recipe list is used in Cohere embedding operator. You can see the recipe list being expanded. So this task will expand depending on the number of recipe lists that we got from the previous task and create embeddings for you to insert into a vector database. And if you know about LLM application, especially retriever-based LLM application, they need all these Weaviate, Pinecone, and PG vector databases. So we have these providers and we have operators in them that helps you to index embeddings and also query for similar vectors. So it's just a plug and play. You just use it without interacting directly with the API to handle your keys and all this. You just use connections to manage your keys. Now, we have developed some use cases, real-world use cases that you can explore to find out how to use Airflow with LLMs. Apart from Ask Astro, we have financial summarization, which you can see the repo here. If you go to the repo, you can see how to use Airflow together with a lot of LLMs, both all the databases, Pinecone, Weaviate, and others. And this is just summarizing seg filings, right? Then we also have Research Generator app, which uses Cohere and Airflow to generate recipes for you. Then we also have a settlement dashboard. So any of these that you feel like you want to learn more about and learn how to use Airflow with LLM, you can just check them out and find out how Airflow was connected, how we use the providers I talked about, the operators with LLMs. Now, to sum it all, Airflow is ideal for LLM apps because Airflow is scalable and it handles retries, dependencies. You can define dependencies and it also alerts you if there are issues. And currently, we are working towards what we call human in the loop, so that when you can interrupt your pipeline and kind of have a human being there to approve everything to continue. It's still being discussed. And one other thing that makes Airflow very essential for LLM apps is because it works with most of the tools that you want to use for LLM apps, such as vector DBs, APIs, cloud storage, or anything. And it's written in Python and with a very good UI. So it's very developer friendly. So final thoughts. LLM apps are not just a single API calls. It's a multi-step pipelines, and that is where Airflow shines very well. It's a really a multi-step, and the path I showed you is just the parts that Airflow handles very well. And Ask Astro is a production-ready example that if you want to go to, if you want to learn about Airflow with LLMs, you can easily go to the repo and check out the code. I've also shown you the web address where you can ask questions about Airflow and find out whatever you want to do with Airflow. So thank you. Yeah, if you want to reach out to me, here is a GitHub address, Iframbody, and LinkedIn Ephraim and Nairobi. Yeah, I would love to hear what you're building. So thank you.